Supervolcano is a word that sounds pretty silly. It's not just a regular volcano, it's super. But these calderas live up to the super in their name. An eruption of that magnitude would fill the atmosphere with ash and sulfuric acid, literally changing our climate for years. Should we be concerned about these mountains of magma? Coming up next, supervolcanoes with geologist Dr. Steve Austin. Hello, my friends. Welcome to Origins. What a joy to have you with us today. My name's Donn Chapman, and I get to be the host. And as you know, Origins is a forum where we take the evidence of science and we use it to validate the truth of creation. And we have a tremendous guest with us today. One of our favorites here on Origins is Dr. Stephen Austin. Dr. Austin, how good to have you with us.
Good to be with you, Don.
We don't just love you because you're a Penn State graduate. We love you because you're a world-class geologist, and you bring us great information that we just don't get anywhere else. So it's really exciting when we have you. Now today you want to talk about supervolcanoes. I just thought all volcanoes were the same, but they're not, are they?
We have different varieties of volcanoes, and we should understand what they're like.
Okay. Let's take Yellowstone as kind of a starting point.
Yellowstone is kind of a classic volcanic area in the United States. We know Yellowstone for its beautiful scenery, don't we? Yellowstone is known for its geysers and for its hot springs, and they are amazing. The variety of geysers and the thermal springs and the mud pots are extraordinary. Perhaps these thermal springs are probably the most beautiful things on Earth.
That's an amazing picture.
Yeah, the bacteria that live in the hot spring are zoned around the temperature, and the high temperature in the middle creates this different colors of bacteria that live in the hot water. These thermal features are just extraordinary. Other things about Yellowstone that are amazing are the petrified wood deposits or petrified logs. And you can see a diagram of the cliff exposure and then internal structure of the layers with petrified logs. We know Yellowstone for the petrified logs. Here's an example of the logs sticking out. We have all kinds of things to ponder at Yellowstone. There you see the Yellowstone Plateau looking south, and you can see the Teton Range in Wyoming. But this plateau in Wyoming is extraordinary, and it's extraordinary from the standpoint of what geologists have recently recognized. It's been only recently that geologists have appreciated this, but the depression in Yellowstone is a gigantic collapsed volcano. And so Yellowstone depression, or what is called the Yellowstone caldera, is this elliptical area that we see here. And this elliptical area is extraordinary. You can see the ellipse. It's about 47 miles by 28 miles in length and width. That is the Yellowstone caldera. The Yellowstone caldera is extreme. 47 by 28 miles. What an amazing place.
It's a national treasure, there's no doubt about that.
Yes, it is. Well, Yellowstone is a picture, provides a glimpse of what a supervolcano is like. And volcanoes we normally think of as nozzles and small eruptions. For example, the size of the nozzle eruptions like Mount St. Helens in Washington State in 1980 are around a cone or a cone type of feature, and they are from a nozzle. a nozzle, a central vent. And they have typically eruptions that are about or to a quarter of a cubic mile of magma that comes out, expresses itself as volcanic ash, typically. So these explosive volcanoes that are small are like Mount St. Helens. And that's the volcanoes we know about, and those are familiar from history. The ones that are less familiar, and the smaller variety that we see, are called ring fissure volcanoes. And they are large. They can be very large. We know about a few small ring fissures, for example, Yellowstone, and eruptions on the order of 2,500 times the explosion power of Mount St. Helens.
Wow.
That's Yellowstone. Yellowstone has more energy than all the nuclear weapons in the world simultaneously detonated. That's a big supervolcano, or a rather average supervolcano, let's say. Large ring fissure. They collapse to form a feature called a caldera. The caldera is the lasting landform from the explosion of that type of supervolcano.
Help me understand, when a ring fissure volcano would erupt, what would it look like? It doesn't have a nozzle where it all comes out.
It starts from a point, and then it makes a crack, and the crack starts extending, and then it turns, and it turns around into an ellipse or into a ring. That's why we call it a ring fissure.
Okay.
So it originally erupts from a point, but then it becomes a line, and it erupts a curtain, not a fountain from one place, but a curtain of magma.
All around.
All around. And so those ring fissures are really big, okay, and can be big. And they leave a caldera. And Yellowstone's a good example. Then we have evidence in the geologic record of gigantic eruptions. So big that it dwarfs the imagination. Well, I'll talk about those type of eruptions. We call the vent type a linear fissure array. Linear fissure array. Now imagine a series of cracks opening up parallel along 100 miles, say, something like that, and not forming an ellipse, but forming a line. The linear fissure array forms a volcanic plateau. And an example might be something like the Colorado Plateau in the western United States, in Wyoming, Colorado, Utah, that type of thing. And because of the understanding of the large and gigantic volcanoes, this understanding of ring fissures and now linear fissure array volcanoes, we are coining the word supervolcano. And the supervolcano are these really huge ones.
Okay.
So Mount St. Helens, just a small to average volcano from the standpoint of human experience in history. There have been a lot bigger volcanic eruptions in history.
Dr. Austin, just to help us understand the scope of these supervolcanoes, if we took Mount St. Helens as a normal volcano, help us to understand how much more influence these have had on the shape of our country.
This diagram illustrates the big volcanoes in the western United States. And there's Mount St. Helens. It erupted in 1980, 1/4 cubic mile of volcanic ash, spread over a smaller area in the northwestern United States. Then we have Crater Lake in Oregon, about 17 cubic miles came out from it in this big blue area here. And then Long Valley in California, right there is the volcano that erupted the Bishop Tuff, about 150 cubic miles of ash. And then we have the 2 Yellowstone eruptions associated here. And the biggest supervolcano at Yellowstone is about 600 cubic miles of ash, making the Huckleberry Ridge Tuff. That is 2,500 times the explosion products of Mount St. Helens.
Wow.
And then we're thinking about Independence Dike Swarm, a series of parallel cracks in California, as being the understructure, the plumbing system of a giant supervolcano that erupted ash that covered the whole western United States.
That's amazing.
4,000 cubic miles of ash forming that enormous plateau, the Morrison Formation in the Colorado Plateau.
Totally changed western United States.
The safe distance to view such an eruption would be a higher orbit of the space shuttle. The formation of pyroclastic flows, we know something about it from those nozzles. When a nozzle erupts, typically there's a dome or a piece of rock that's in the way. It's got to fall away. And as the rock or the top of the volcano falls away, it exposes magma, and then the explosion occurs, and we have a vertical eruption. That's the eruption column, and that can often generate a pyroclastic flow. And pyroclastic flows are the most severe of the volcanic type of phenomena. More geologists die in pyroclastic flows than in any other geologic process. It's extremely hazardous. Now there is Crater Lake in Oregon. What a beautiful place. 6 miles in diameter. Okay, it has a little Wizard Island in there in the center there. That's that landform feature, you know, that's the central cinder cone. But we see all around it the giant collapsed debris of the volcano. That is extraordinary. Long Valley Caldera in California, though, near Mammoth, north of Bishop, California, that's 20 by 10 kilometers. And that was the source of the Bishop Tuff and that enormous volcanic eruption in central eastern California. And those are extraordinary eruptions. And we think we understand how those kind of eruptions occur. Magma gets up to within 5 or 10 kilometers of the surface of the Earth, depth of maybe 5 miles. And as the magma gets up there, it expresses itself and breaks the surface in a crack. And the crack wraps around itself above the lava magma chamber, and it erupts a curtain of magma, and then the ground collapses. As the magma is issued out, it collapses and forms a caldera. And then the third type of volcano that we can infer is what's called the linear fissure array. And the linear fissure array is well illustrated by what's called the Independence Dike Swarm in eastern Southern California. And there's a series of linear cracks that are filled with molten rock, which has not issued out to the surface. So we call them dikes. And this is the substructure, we believe, of the supervolcano. There was a big volcano or supervolcano above. Perhaps the best place to see the supervolcano is in the Inyo Mountains of California. But we see the debris that sat on top of the supervolcano in certain places. But we see the underground plumbing system of the volcano expressed in eastern California and also down in Baja California. And so it's extraordinary to think about this. Well, what would a supervolcano look like from a linear fissure array? It would be extreme. And we think that the Morrison Formation, that's the dinosaur layer in the Colorado Plateau, is the eruption deposit from the supervolcano in Southern California.
How many miles apart is that?
Okay, we're talking hundreds of miles here.
Hundreds of miles.
Hundreds of miles. So there are fragments in southeastern Utah and in southwestern Colorado.
What we call the Four Corners region.
The Four Corners region. There are fragments that are dime size. You know, dime size volcanic particles that we think came from California, probably ballistic trajectory.
Probably 600 miles.
600 miles. So they had to be lofted into space.
Think of that.
Apparently, that's the distance that these particles have moved.
And the theory is that there was so much of it that it came down and buried the dinosaurs.
And buried the dinosaurs. That's what we're starting to think that way. Here is the Morrison Formation in Utah and Colorado. We see the very beautifully displayed purple and reddish layers with the gray volcanic ash all around it. Hundreds of feet in thickness form a major part of the Colorado Plateau. This is from the supervolcanoes in Southern California. erupted hundreds of miles and found out here in Utah and Colorado. Most famous exposure of the Morrison Formation, the volcanic ash deposits, is at the Visitor Center at Dinosaur National Monument. And at Dinosaur National Monument, we see a thick layer of sandstone, about 50 feet in thickness, in between the volcanic ash layers of what's called the Brushy Basin member of the Morrison Formation. The Brushy Basin volcanic ash is about 400 feet thick, and it is the supervolcano residue. And in the middle of this is a sandstone with dinosaur fossils, and the wall at Dinosaur National Monument. So there you see it, the very beautiful exposure, the Morrison Formation there in the, all the way up from Canada, all the way down almost to Mexico. It's a huge area. There's 4,000 cubic miles of volcanic ash in that terrain.
The whole face of the western part of our nation was reshaped by that, wasn't it?
It was reshaped.
Yeah.
In a supervolcano of colossal size. And in between there, in the sandstone layer at the Dinosaur National Monument, in this layer in there is where we see the dinosaurs, evidently swept up in mud flows during the supervolcano explosion.
Wow.
The Brushy Basin member of the Morrison Formation, the supervolcano deposit, is about 470 feet thick at Dinosaur National Monument. It thins out to the east and north. We think the source is in California. It's an amazing place. There you see the wall at Dinosaur National Monument. You see 1,500 bones on the quarry face, and you can see articulated skeletons of dinosaurs, the hip, and lots of the forelimb, even skulls of dinosaurs are very well preserved. Now you know the rest of that story. The dinosaurs directly experienced some type of volcanic and sedimentary disaster. Here we see the satellite image of northwestern Mexico. And you can see Arizona over there, and you can see Gulf of California, Baja, and then you see Sonora, Mexico. Sonora, Mexico, extending from Arizona all the way down into southern and central Mexico. This giant area is called the Sierra Madre Occidental, and it is a gigantic platform or plateau formed of volcanic ash deposits. Geologists have not been able to find any calderas buried. And because there's no caldera buried there, or it's not been found, geologists believe that that is a giant supervolcano plateau. And so volcanoes have erupted on a colossal scale, and Sierra Madre Occidental is one of those colossal remnants of a supervolcano. So
Dr. Austin, it's amazing to me the scope of this. It's just so huge, and we want to talk about this. We want to talk about the implications, but we have to take a break. So you stay right there, and right after this break, we'll come back and see just the enormous effect of these supervolcanoes. Don't you go away.
Today's guest on Origins, Dr. Steve Austin, is a field research geologist with his PhD in sedimentary geology. He is the senior research geologist with Logos Research Associates and teaches geology at Cedarville University in Ohio. Steve has done extensive work all over the world, especially at the Grand Canyon and Mount St. Helens. He is the author of many books, videos, and more than 30 technical geology papers. One of his videos deals with the 1980 eruption of Mount St. Helens. To order the DVD, call 509-551-5343. To contact Dr. Austin, write to Logos Research Associates, 3232 West MacArthur Boulevard, Santa Ana, California, 92704.
We are back with our guest, Dr. Steve Austin. We've been talking about supervolcanoes and the part that they've played in the formation of the Earth we live on. Have they changed history? Can you talk to us about that?
Will Durant said it in a rather humorous quip. He says, civilization exists by geologic consent. Well, really, civilization exists by God's consent. But the idea is that man has little to do with history, and there's something else that changes history. Could it be volcanoes have changed history? And volcanoes that have changed history, I might just point to a few and talk to you about the possibilities. For example, Mount St. Helens erupted there in 1980. In 1980, May 18, 1980, Mount St. Helens erupted, and it is probably the most publicized volcano in history. But there have been bigger volcanoes, such as Krakatoa, 1883. It erupted there between Java and Sumatra, August 1883, and it left a caldera, and there were red sunsets for 3 to 5 years following that, and global impacts, a slight impact on weather. Tambora erupted in Sumatra, and Tambora, 1815, it caused the next year, 1816, it's been called the year without a summer.
Wow.
In the northern hemisphere, in northeastern United States, lakes were frozen in July.
Wow.
Okay, something happened to the summer of 1816. And there was some epidemic disease and some other things that made 1815 and 1816 extraordinary years. Anyway, Iceland erupted in 1783, and Benjamin Franklin was referring to that. He said there's a dry fog or haze over the world that he knew. And evidently, back there about 1258 through about 1345 AD, there were large eruptions somewhere. We can see the volcanic evidence in the acid ice from Greenland ice core. But there seems to be some volcano weather associated with that. I believe that 536 AD was an event caused by a volcanic cloud. A volcano or maybe a meteorite explosion associated with about the spring of 536 AD created a global ash cloud, some kind of global ash cloud. And the sun was only seen in the sky for 4 hours a day for about a year.
Wow.
And the atmospheric transparency was altered. And of course, we had plague epidemics that followed, and the demise of Justinian's Byzantine Empire. 186 AD, big explosion on Taupo in New Zealand. And everybody knows about 79 AD, that eruption, Vesuvius, it buried the town of Pompeii. And 44 BC, when Caesar died, the sun felt pity for Rome, and 4 suns were seen in the sky as Etna erupted there west of Italy. And then we see the big volcanic eruptions perhaps associated with Thera. Thera is a volcano in the Aegean Sea. It erupted violently, maybe about the time of the epidemic plagues in Egypt. So Mount St. Helens is a volcano that is in memory, but Yellowstone is this gigantic collapse feature, this supervolcano. Yellowstone provides a picture to help us understand volcanoes of the past.
Well, I find this to be extraordinary information that, frankly, much of it is new to me, and it makes me realize that God used volcanoes in a far greater way than I ever realized to really reshape the earth for us for this period of time.
Yeah. Without the effects of volcanoes, this would be a very different earth than we've experienced today.
It is. So it's one of the arrows in God's quiver, something that He uses as He works out His plan.
And we can understand the magnitude of geologic power of the past, maybe even the global flood of the past, by looking at these volcanoes that provide this window to and a picture of the past.
Thank you for sharing with us today. I've learned a lot, and I'm sure that our viewers have as well. Thank you for the work you're doing and for the confirmation that God is in charge and that He is using all kinds of events in history to work His plan. You know, the one thing I know is that because Jesus Christ is my Savior, His plan for me goes way beyond this earth. And whether it's destroyed by water or by fire, one day I'm going to be home with Him. And that means the most to me, and I'm sure you agree with that as well. God bless you, Brother Austin. It's good to have you with us. You know, my friends, God can send all kinds of catastrophes that can change the shape of the earth. But you know, He sent His Son to change the condition of your heart, because His ultimate goal is for you to be with Him. And friend, as you're looking at what's happening in this world, always remember it's God's view that He created you. And that should be the center of your worldview too. I hope you'll join us again soon here on Origins. And until then, God bless you, my friend.
Thank you for watching this edition of Origins. If you'd like a copy of the PowerPoint information presented today, you can download a PDF file from our website at www.originstv.org. Or for a DVD of this series, send a $12 donation to cover shipping and handling and write to Origins, program number 1210, Cornerstone Television, Wall, Pennsylvania 15148.
Origins is made possible by the faithful prayers and the financial support of you, our Cornerstone Television family.